আমি আগে না এটা শেয়ার করে নেব নাকি প্রথমে নাকি
স্যার
welcome friends, welcome to all of you. Today we are welcome to all of you. So today we are welcome friends to first live session of this rerun course of environmental soil chemistry. And in today's session we are going to discuss some of the important aspects which you have asked in the forum, course forum. Also, we are going to discuss some of your queries which you have raised in the shared Google Sheet. And also, I'm going to discuss some of the slides which you have asked me to re-explain. So let me share my screen so that this is so let me share my screen so the things will be clear to you. So I hope that my screen is now visible to all of you. So this is our live session 1 and of this rerun course of environmental soil chemistry. And as I have told you, we are going to discuss about question asked in the shared Google Sheet. Then we are going to discuss the question asked in the forum, and also we'll discuss the types of the question which the types of the question you can expect in the final exam. So guys, first of all, let me go through the week-wise lecture. So I hope that we have finished so far up to week 5. So we started our lectures of this course with an evolution of soil chemistry, where we discuss the definition of soil chemistry, and then difference between the soil chemistry and environmental soil chemistry, and how this soil chemistry discipline has evolved over a period of time, and what are the important aspects of environmental concern of contemporary world we have discussed. So in the second week we have discussed the inorganic soil components. Now these inorganic soil components, as you know, we started with discussing the Pauling's rule, all the rules which are required for understanding the crystallographic nature of secondary soil minerals or clay minerals. We have discussed them in details, specifically Pauling's rule 1, 2, 3, 4, and we have also discussed the coordination number, radius ratio, what are the limiting radius ratio for different coordination number, what is no rattle limit, and then how, depending on this radius ratio, the coordination number changes from one coordination compound to another coordination compound. So this is the second lecture, topic which we have discussed in week 2. In week 3, we have, and also we have discussed what are the implication of these crystallographic structures. We have discussed in details about different clay minerals like kaolinite, montmorillonite, illite. Also, we have discussed the different aspects and different properties of distinguishable properties of those clay minerals. In the week 3, we have discussed the chemistry of soil organic matter, and here we have discussed about humus, the structural composition of humus, and different pathways of the humus, how humus generally forms, and how negative charge develops in the soil organic matter, and what are the ways to fractionate the soil organic matter. We have discussed in details. And the fourth week, we have discussed about the soil solution, solid phase equilibria, and sorption in soils. Inner sphere complex, outer sphere complex, we have discussed. And then in week 5, we have discussed the cation capacity, also anion capacity, and also we have discussed the different numerical problems related to cation capacity, and how to calculate and how to estimate the cation capacity of the soil, and how to what are the different methods of estimation of cation capacity of the soil. Now, in the coming weeks, we'll discuss the kinetics of soil chemical processes, different orders of reaction, and also in week 7, we'll discuss the redox chemistry of the soil, which is very important. And then the redox chemistry, when we discuss about the redox chemistry, we'll discuss in details about the different types of chemical changes which you can expect when there is a submergence condition and the waterlogged condition. So we'll discuss that also. And then in week 8, we'll be discussing the soil pollutants. What are the different types of inorganic pollutants? What are their different properties? And then week 9, we'll focus on pollutant soil solution interactions, how different types of pollutants interact with the soil solution. Week 10, we'll discuss about the retention of pollutants and on and within the soil solid phase. And week 11, we'll be focusing on modeling the fate of pollutants in the soil, and then identifying their risk and identifying their solution or remedies. And finally, in week 12, we'll be discussing different advanced analytical techniques for assessing soil pollution. So this is, in nutshell, the topics which we are going to cover in coming weeks. And hopefully, whatever we have covered so far, you have understood, and you have raised several questions in the forum, and I'm going to discuss all those questions in today's live session. Okay, guys. So the first question came. What will be the question pattern in the final exam? Well, in the final exam, all questions will be MCQ types, that is multiple choice question, and duration will be around 3 hours. And there are mainly 3 types of question. One is assignment type of question, second is recall question, and third is open question. There will be 15 assignment question, 10 recall questions, and around 25 open questions. So in total, there will be 50 questions, and each question will carry 2 marks. And of course, as you expect, there will be numerical questions. So numerical questions should be, you should prepare to answer the numerical questions in the exam. Now, recall questions. So what are the recall questions? Recall questions are questions based on recall from the video lessons created. Okay, so we have already seen in these 5 weeks, we have already encountered, we have seen 25 different lectures. So these 25 different video lessons, and also in the coming weeks, a total 60 video lectures will be there. So total 60 video lectures will be required for answering this recall type of question. So, and the second type of question is assignment questions. So these assignment questions are based on the assignment. So at at the end of each and every week, you are having an assignment. So there will be question based on the assignments, which are similar to the similar to those asked, but with different set of numbers. And finally, there will be questions that test the candidate's understanding of the concepts to differentiate one candidate from other candidate. So these are known as the open questions, and this question will test your understanding of the concept. So the recall questions and assignment question will come from the video lectures and the assignments which we will be posting after each week. However, in case of open question, you can expect some question based on your understanding. Now, one of the students have asked, what will be the criteria or weightage of assignments and also the final exam, for calculating your the marks for passing the course. So a learner will pass and be certified only if the average assignment score, which is out of 100, will be greater than 40, and final exam score, which is out of 100, will be greater than 40. So that is, to clear the exam, you have to score a minimum of 10 out of 25% in the assignment and 30 out of 75% in the final proctored exam. So this is how these are the criteria for passing the exam and getting the certificate. So I hope that your answer have been your question has been answered. Now, the next thing is, somebody has asked, that is, what is the utility of the NPTEL? In the shared Google Sheet, you have asked that what is the utility of the NPTEL. I don't think that I need to discuss this utility of the NPTEL, because you all know about this utility of this NPTEL. But again, I would just like to give a broad overview of why we should take NPTEL course. The main goal of NPTEL is to create web and video courses in all major branches of engineering and physical science at the undergraduate and postgraduate levels, and management courses at the postgraduate level. So if you are a science graduate or if you are an engineering graduate, it is not possible for you to take all the courses in your university or institute. So together, but you have to enrich yourself with enough knowledge with these courses, which may not be available in your institute. So these NPTEL lectures are required. I mean, there are several courses in the NPTEL, and these NPTEL courses will enable you to gather these extra knowledges or extra expertise, which you cannot get in the traditional courses which are offered by your universities. Okay. Secondly, it is the largest online repository in the world of courses in engineering, basic sciences, and selected humanities and social science subjects. And you can see there are, in the online web portal of NPTEL has more than 471 million views. And you can see there is a YouTube channel for NPTEL, which most subscribed educational channel, which is 1.5 million, more than 1.5 million channel subscriber, and more than 890 million views, and more than 50,000 video hours. So it shows that how this NPTEL has served as an important educational source for millions and millions of subscribers and also the students. Secondly, more than 54,000 hours of video content and transcribed with subtitles are available. So you can take a look, and most assessed library of peer-reviewed educational content in the world. So this is, this shows in a nutshell the importance of NPTEL, and one of the major benefit of Indian students for taking the NPTEL course is most of the universities now accepting this course for credit transfer. So you can transfer some credits if you have taken this course towards your degree requirement, and that will be really helpful for your for getting your degree and also simultaneously selecting the desired course which you require for enriching your knowledge in a specific domain. Okay. Uh, Now, you also utility of NPTEL, you can see there are 4, 8 and 12-week online courses which are typically on topics relevant to students in all years or higher education, along with the basic core courses in science and humanities with exposure to relevant tools and technologies. So, that shows the importance of NPTEL. The next question which was asked was, what is the difference between point source and non-point source pollution, and what are the sources of point and non-point source pollutions? Okay, so so let me answer this question. We have already discussed this thing in the lecture, but let me repeat this thing. So there are two basic types of pollution. Okay, uh, one is point source pollution. The point source pollution is a contamination that can be traced to a particular source, such as industrial site, septic tank, or wastewater treatment plant. So you can see here, these are the particular source from which this wastewater or industrial water or industrial water or wastewater treatment, wastewater discharge water are releasing to bigger water body, and these are known as the point sources of pollution, or in other words, it is known as the point source pollution. Now, according to the US EPA, or United States Environmental Protection Agency, any single identifiable sources of pollution from which pollutants are discharged, such as pipe, ditch, ship, or factory smokestack, are, they come under the point source pollution. Now, factories and sewage treatment plants are two common types of point sources. Now, what are the non-point source pollution? What is non-point source pollution? As you can see, the surface runoff from the agricultural fields, when they reach the nearby water body, this is a non-point source pollution, because here the pollutants are coming from different sources. It is not a single point source. So this non-point source pollution results from large areas and not from any single source, and includes both natural and human activities. What are the different sources of non-point source pollution? One is agricultural, then human, then forestry, urban, construction and mining activities, and atmospheric deposition. These are the sources of point source pollution. However, what are the sources of non-point source pollution? Geologic erosion, saline seeps, and breakdowns of minerals of the soils. These are some non-point source pollutants. So if you see this picture, it will be more clear to us. If you can see, there are different types of non-point source and and also point sources. For example, here you can see point sources like wastewater treatment plant. The effluents are coming from the wastewater treatment plants, and also the effluents from the factories are coming from here. The wastage materials from the animal feedlot are coming and then mixing with the water body. So these are some of the point sources. However, what are the non-point sources? Suppose there is a rainfall, and this rainfall is washing away all the animal feed loss, and also the croplands and the rural households, and also the suburban areas, and also urban streets. And all these pollutants with mix with the stormwater or rainwater, goes as a runoff and mixed with the water body, and these are the this creates the non-point sources. So these non-point sources, you can see non-point clear distinction between point source and non-point source pollution. When we are seeing the pollutants coming from a point, that is from the factory or wastewater treatment plant, we call it point source pollution. However, in other cases where it is not possible to distinguish different sources of pollution, and it is come as a bulk from a big area, then it is called non-point sources. Now the next slide will show the effect of one of the important point source pollution in China. So we can see here Water in many central China's rivers are greenish black from uncontrolled pollution from thousands of factories. And these point source pollution creates this type of polluted water system, uh, and it is quite clearly visible that how these industrial effluents are creating or vitiating the environment from different point source pollution. Now, point source pollution, one thing you have to understand that the point source pollution is easy to identify. That, as the name suggests, it comes from a single place. And non-point source pollution is harder to identify and harder to address. It is pollution that comes from many places all at once. Now, factories, as I have already told you, that factories and power plants can be a source of point source pollution, affecting both air and water. And smokestacks also releases carbon dioxide, heavy metal, sulfur dioxide, nitrogen oxide, or particulate matter into the air. So this is a point source pollution. And also oil refineries, paper mills, auto plants that uses water as part of their manufacturing process can discharge effluent wastewater containing harmful chemical contents or chemical pollutants into rivers, lakes, and oceans. So all of these are point source pollution. Now, municipal wastewater treatment plants are another common source of point source pollution. I've just shown you. And also effluents from treatment plants can introduce nutrients and harmful microbes in waterways. So nutrients can also cause a rampant growth of algae in water. Just I have showed you in our previous slides that how this point source pollution is creating or polluting the water body in China. So that is due to the rampant growth of algae in water. And also non-point source pollution is the opposite of point source pollution with the pollutant release in a wider area. I have already discussed from agriculture area, for example. So I hope that with this discussion, it is now clear to all of you what is the difference, what is point source pollution and what is non-point source pollution. And then what are their characteristics and what are their different sources. Now, next question which you have asked, that is difference between soil chemistry and environmental soil chemistry. Soil chemistry, well, there is a clear difference between soil chemistry and environmental soil chemistry. Now, soil chemistry is a branch of soil science that deals with the chemical composition, chemical properties, and chemical reaction of the soils. And soil chemistry has traditionally focused on the chemical reaction in soil that affect the plant growth and plant nutrition. So generally, when we talk about soil chemistry, these are the chemical aspects which are related to the plant growth and plant nutrition. However, when we talk about environmental soil chemistry, this involves the study of chemical reaction between soils and environmentally important plant nutrients and radionuclides, and then metals, metalloids, and organic chemicals. In the coming lectures, in the coming weeks of lectures, there will be more, we'll be more discussing about these, radionuclides, radionuclides, then plant nutrients, metals, metalloids, and organic chemicals. And things will be more clear that why this course is named as environmental soil chemistry. However, for understanding the environmental soil chemistry in a better way, you need to have the basic knowledge of soil chemistry. So in other words, this environmental soil chemistry is directed towards addressing some of the environmental pollution aspects. So it is more focused towards environmental pollution as compared to the soil chemistry, which is traditionally addressed towards growth and nutrition of plant. Now, environmental soil chemistry is fundamental in predicting the fate of contaminants in the surface and subsurface environment. It is also necessary to comprehend the array of chemical reactions that contaminants may undergo in the soil environment, which may include equilibrium and kinetic processes such as dissolution, precipitation, polymerization, adsorption, desorption, and oxidation reaction. So all these lectures, these 60 lectures will explicitly discuss these different processes or kinetic processes to which are involved for explaining the dynamics of environmental pollution or environmental soil pollution. Remember, these processes affect the solubility, mobility, speciation, toxicity, and bioavailability of the contaminants in soil, in surface water, and groundwater. So this is how this environmental soil chemistry is more specialized and separate from the traditional soil chemistry. And this course will focus on this environmental pollution aspects. Okay. Another question you have asked, that is how the different contaminants reacting with soil and water. Now, this thing will be more clear in our coming weeks of lecture. So I'm not going to discuss this in details, because in the coming weeks, you'll be seeing the different pathways through which these contaminants interact with water, and also different models which can predict their persistent and what are the different types of remedial measures to solve this environmental pollution. But just for a very brief overview, you can see here this figure. You can see that there are point source pollution, and you can see runoff and wastewater is coming out from the industries, and there are also seepages and runoffs and groundwater discharge into streams and seepages. So generally, different components reacting with the soil when they are moving through the soil, and then when they are coming in contact with the water bodies. So point source pollution or contamination can be traced in specific points of discharge from wastewater treatment plants and factories, as I have already told you, and also the non-point source pollution where there is no traceable, clearly traceable source. However, these different contaminants from different sources, when they move from one place to another place, due to the different types of properties of soil, like their their retention in the soil and their characteristics of the movement through the soil, they will vary from one soil to another soil depending on different types of soil properties. Redox properties, whether the soil was enough oxidized or not, or whether that the soil is submerged or not. So these properties will determine the different species of contaminants. Some species will be more toxic in their oxidized states. Some species will be more harmful in their reduced states. So depending on different types of factors, they will react with the soil and water, and ultimately they will pollute the environment. Okay, next question. Another question came from you guys, that is fertilizer consumption in India and pollution due to excess fertilizer application. Well, this is a very good question, and I think that we should discuss this in detail, because in this course we didn't have enough scope to discuss the detailed scenario of fertilizer consumption in India. And this condition will be also, this discussion will also help the others from other countries to relate the harmful effects of excess fertilizer applications also. Now, data shared by the government of India recently indicated that the consumption of chemical fertilizers have increased by around 16% between 2015 to 16 and 2020 to 21. Now, from about 510 lakh metric ton in 2015-16, the consumption increased to around 590 lakh metric tons as per provisional figures for 20 21. Now, even the consumption of chemical pesticides are also increased during this period. So we can see that there is a steep increase of consumption of both fertilizers and pesticides in India during this period. Now, on average, India consumed about 500 lakh metric tons of fertilizer per year in the last 10 years. Now, urea, among all the fertilizer, urea, which is the source of nitrogen fertilizer, is the most consumed fertilizer with around 300 lakh metric tons, which is being consumed each and year, accounting for 55 to 60% of the chemical fertilizer consumption in the country. Now, between 2016 to 17 and 2019 to 20, there has been a steady increase in the consumption of urea, DAP, and NPKs. DAP is diammonium phosphate, which is a phosphatic fertilizer, and NPK fertilizers are also there. So we can see that there is a steady increase in fertilizer consumption, be it a urea, DAP, or different NPK fertilizers in Indian condition. Now, even though the data is only up to February 2021, the consumption of the DAP and NPKs is already the highest in 2020-21 in the 6-year period from 2015-16 to 2020 to 21. So you can expect that the total consumption of this year, that is 2021 season, will be more higher as compared to the 15 to 16 season. So there is a steep increase in consumption of these fertilizer from these last 6-year periods. The final quantity of the urea consumed in 2020-21 might also cross the 2019-20 levels, making the consumption highest in 2020 to 2021. Okay, so the final quantity of urea, also it will cross. So it is continuously growing. So if you see the picture here, it is quite clear that fertilizer consumption in India and pollution due to excess fertilizer application. You can see here, these are the urea. So you can see from 2015 to 16 to 2020-21, there is a continuous increase in urea consumption in India. Same goes with the DAP consumption. And also MOP is more or less constant. However, there is a slight increase from 2015-16 to 2017-18, and then become more or less stable. However, for NPK fertilizer, there has been a continuous increase from 2015-16 to 2020-21. And remember, this 2020-21 data is calculated up to February 2021. So we can assume that the total consumption of urea in this duration ultimately for this 2021 will be much higher than that of the present presently calculated fertilizer for 2021, which is up to February of this year. Now if you see the consumption of major fertilizer by states, so you can see that several states are having high amount of fertilizer consumption. In some areas there are some you can see in case of Chhattisgarh there is a in case of Delhi there is an increase, and also for other areas also in Karnataka also we can see some increase. Now if you see the overall picture, now Bihar topped the list in 2019-20 with respect to the per hectare consumption of fertilizers, closely followed the Puducherry in spite of its small size. So Puducherry has a high amount of fertilizer application. Punjab, Haryana, Telangana are among the top 5 states or union territories which have all reported consumption of more than 200 kg per hectare in 2019-20. And these 5 states or union territories have also consistently reported consumption of more than 200 kg per hectare in the 5-year period from 2015-16 to 19-20. Now, among these, Puducherry has consumed nearly 406 kg per hectare fertilizer in 2015-16, and these 5 states constitute the top 5 in no particular order since 2017-18. So you can see that how different states are having high amount of consumption of fertilizers. Now, on the other hand, just the opposite scenario, you can see Kerala and Jammu and Kashmir are among the major states or union territories that have the least fertilizer consumption. So, that gives the basic overview of the fertilizer consumption scenario in India. Now let us see what are the ways to deal with this excess fertilizer application. Uh, then you can see that there are all India coordinated research projects on long-term fertilizer experiments over 5 decades at fixed sites, which reveal that the continuous use of nitrogenous fertilizers alone had a deleterious effect on soil health and crop productivity, showing deficiencies of other major and micronutrients. So that shows when you go for the continuous application of chemical fertilizer, which are chemically synthesized fertilizer like urea, DAP, NPK fertilizers for long-term fertilizer trial, that reduces the native fertility of soil and also ultimately showing the deficiencies of other major and micronutrients. So even with recommended dose of NPK and more, deficiency of micro and secondary nutrients have become ill limiting factors over the years. So this is very important, that shows the importance of reducing the dependency on excess fertilizer application. Instead, we should move towards integrated nutrient management where inorganically synthesized fertilizer should be applied along with organic fertilizer, organic manure in a judicious manner for sustaining the environment so that there is no substantial decrease in native fertility status of the soil. This is very, very important. So guys, that is why we should be very, very careful. I mean, apart from pesticide, increasing the amount or indiscriminate use of chemical fertilizers for, indiscriminate use of chemical fertilizer results in reducing the fertility status of the soil in a long run. And we should be very, very careful about that. Now the next question, see, so we have seen that recommended soil, government of India has recommended the soil test based balanced and integrated nutrient management, or in short we call it the uh, INM, through conjunctive use of both inorganic and organic sources of plant nutrients to prevent the damage to natural sources. And the government is also advocating the concept of balanced and judicious use of fertilizer in conjunction with biofertilizer, organic fertilizer, and farm manure. And I can see here that Aussie has correctly mentioned here that use of PSBs and so that is phosphate solubilizing biofertilizers and nitrogen fixing biofertilizer and KRBs microbes unlocks these NPKs. So yes, it is correct that apart from using these inorganic fertilizer, if we in the integrated nutrient management concept, if we go with the organic fertilizers and also use of biofertilizers, that biologically reactive organisms, to increase the availability of the nutrients, specifically nitrogenous biofertilizers and phosphatic biofertilizers, so that will increase the native fertility status of the soil. Also, Aussie has mentioned that to reduce my soil, there is a SOC home test. I can do it test, proving my recharge is complete. I want it without composting. Yes, I mean, you can do that, is there any SOC home test I can do to test? Okay, so Aussie has asked one question in the chat box, that to reuse my soil, is there any SOC home test I can do to test with proving my recharge is complete? I want without composting. So I want to amend it with enhanced vermicomposting. Is Munsell chart good enough? Maybe a number would be nice too. Now it is a very good question. You know, generally for estimating or identifying the organic carbon content or organic matter content, so far there are certain people have followed certain methodologies. We call them wet chemistry tests. What are these wet chemistry tests? The Walkley and Black test of organic carbon, and then we convert this organic carbon into the organic matter. In the Walkley Black test, it is laboratory based test. But if you want to assess the organic carbon content in the of your soil without doing the time consuming wet chemistry tests, it is now possible. There are certain advanced and cheap alternatives available in soil science nowadays. For example, our group at IIT Kharagpur or Indian Institute of Technology Kharagpur, and also several other scientists at different parts of the world, has utilized the smartphone based testing of soil organic carbon by image processing. And we have developed an app, and we are currently modifying it also. So you are welcome to see our research, where you can see that we have utilized these cheaper tools like smartphone image processing for identifying the organic carbon content or organic matter content. And that will be useful for you because you do not need to process your soil sample for just like in case of traditional soil testing. And also it will give you instantaneously result based on advanced machine learning approaches. So there are other tools which are available. There, one of these tool is Nix Pro. You can see this Nix Pro tool in the week 12 if I can remember. But you can also search in the internet. This Nix Pro is a color sensor tool which is Bluetooth operated. Now this Bluetooth operated Nix Pro tool will be also useful for identifying the organic carbon content. And there are, in last couple of years, there has been a huge amount of research of application of these tools for rapid identification of organic carbon. So you can search in the internet, you can search the literature, and you will see that the smartphone based tool and Nix Pro based tool have been extensively used for identifying the organic carbon content without doing the wet chemistry analysis, traditional wet chemistry analysis, in a very short period of time. And that will give you some, instead of using the Munsell soil color, the Munsell soil color chart is qualitative because my colors perspection will vary from your colors perspection. However, to give it a quantitative look, we have used this smartphone as well as Nix Pro color sensors for identifying or modeling, in other words, the organic carbon content. You can check these different sources, and you will find this type of sources, and these are very cheap. You can access it from Amazon or other online sources, and you can use this, and you can use this model for rapidly measuring the organic carbon content. So I hope that I have given you this answer. Now, image processing, in other words, image processing is an option to go with for rapid measurement of several soil properties instead of doing the property analysis in the lab using time consuming wet chemistry methodologies. And there are plenty of methodologies available in the literature. Please go through those. And if you are, you are more than welcome uh, to shoot me an email, and I'll be giving you, I can help you to give more information on those resources so that you can take a look and you can develop your own method for rapid screening of soil organic carbon. Thank you. Now, okay, another question comes from you, that is, what are the job opportunities? Now, if you take this environmental soil chemistry course, it's a very good question, and I appreciate your candor for asking this question. Now, if you have taken this course of environmental soil chemistry, there are different agro-based industries nowadays, and these agro-based industries always seek for soil scientists. So if you take this course, it will be really helpful to get absorbed in those agro-based industries, and this type of course will give you an extra edge as compared to other people, so that where you will be enriched by different tools of soil testing, different aspects of soil testing, and also different thorough knowledge of soil to describe any process, be it from the plant nutrition point of view or from environmental point of view. So you can explore the soil from both point of view, from the plant nutrition point of view or from the environmental point of view. For gaining more knowledge about plant nutrition point of view, you can take a look on in the soil science and technology course which I've offered previous years. So that will give you a more overview of soil chemistry, and this course will give you overview of environmental soil chemistry, which will be helpful for identifying the environmental application of soil. And also soil chemistry in government agriculture departments, there is always requirement of soil chemists. So if you have taken this course, you can be you can find yourself in the government agriculture departments also. There are several academic jobs in universities and government organizations. You can act as a farm manager. You can act as an environmental analyst in government pollution control boards. Each and every province of India has their own pollution control boards. So you can be, you can get the chance as an environmental analyst there. And also you can serve as a lab or field chemist. And also there are academic jobs are in environmental sciences. So these are different types of job opportunities if you have taken this course, and you can utilize this knowledge of this course if you have if you are involved in any of these profession, you can utilize the knowledge which you gather from this course. Okay. There have been some requests. There's been some requests for explaining some specific slides. So these slides I'm going to discuss here. So one slide is the 2 plant nutrients of greatest concern. So this is from our first week of lecture. So the 2 plant nutrients of greatest concern is surface and groundwater are nitrogen and phosphorus, and their impact on water quality too. Obviously, because these nutrients, when they enrich beyond a certain point, that encourages the growth of algae and ultimately reducing the dissolved oxygen. And so the US EPA has established a maximum contaminant level, or we call it MCL, of 10 milligram per liter nitrate as nitrogen for groundwater, whereas total phosphate not exceed 0.05 milligram per liter or ppm. And in a stream where it enters lake or reservoir, and that total phosphorus in streams and that do not discharge directly to lake or reservoir not exceed. So these are different types of maximum contaminant levels which we should not violate. Otherwise, there will be negative consequences, because when there are an excessive nitrogen and phosphorus, what will happen? There will be eutrophication of water bodies, and then creating excessive growth of algae and other problematic aquatic plants. So when there is an eutrophication of water bodies, that means there will be more growth of algae. So that will create excessive growth of algae and other problematic aquatic plants. And ultimately, these aquatic plant growth or algal bloom will create the hypoxia. That means they will use up all the dissolved oxygen, creating very low level of dissolved oxygen. And this low level of dissolved oxygen is very harmful for the aquatic organisms. So this is how they create the negative impact. Now, excessive nitrogen in the form of nitrates has also been linked to methanoglobamia or blue baby syndrome, which is a deadly syndrome, disease. Abortion in women in increased risk of non-Hodgkin's lymphoma is also there. As phosphate is tenaciously held by soils through both electrostatic and non-electrostatic mechanism, because clay develop negative charges, and these negative charge impact, these negative charge, and also clay develop positive charges, as you have known now. So these positive and negative charge development, when there is a positive charge development at the edges of the clay, they attract these phosphate anions, and so they attach these phosphate anions so that they do not usually leach in most soils. On the other hand, nitrogen is weakly held in by the soils and readily leach in soil. So nitrate is highly mobile in the soil. They are the major sources of nitrogen and phosphorus in the environment. Inorganic fertilizers, animal manure, and also biosolid application, septic system, and municipal sewage system. So these are the sources which can create this eutrophication in water bodies. For example, inorganic fertilizers, also animal manure, biosolids, septic systems, and effluents from municipal sewage system also contain huge amount of nitrogen, phosphorus, and that create, when they reach in a water body, and then they will create the eutrophication. Okay, Ossie has asked another question that I need help wrapping my head around electron donor and acceptor. Oxygen accept, yes, but is there an easy technique formula to remember this, please? Unfortunately, there is no easy technique formula to remember it, please. But it is a very good question. I'll see if I have a better answer for that. Please, mark this question in our class, discussion forum, and I'll try to see if I have a better answer for that. Until now, I do not have any better answer for this, any easy technique or formula to remember. But I'll try to see if I can find. I'll keep you updated. Okay, thank you. So, guys, this wraps up our discussion in this first live session, and I hope that I have discussed the most of your questions which you have asked, and in the course forum. And if you have further any questions, please shoot me an email. You know my email, I have given it in my NPTEL. So you can send me an email, or you can ask directly in the course forum, and I'll try my level best to answer those questions. Okay, and I hope that the preliminary questions which we have already asked from these 5 weeks, I have been, I have answered those. And if you still have any questions, please feel free to let me know, and I will try to give you more, and I'll try to give you the answer. Okay, and thank you for joining in this live session, and best of luck for the rest of the course. And I wish you best of luck for your exams also. Thank you very much.
স্যার শেষ করে দিয়েছি স্যার কমপ্লিট স্যার
স্যার বেরিয়ে গেলেন।